All right, everybody, welcome. It's Tuesday, and we are just over halfway through chapter 2, where we're just solving. We're solving and solving and solving, right? You're probably tired of solving already, but we're gonna do more because we're gonna learn a ton of solving skills this chapter, and things that we'll use often throughout the year. So we're just kind of cramming it all in here, and yeah. So today we're solving equations, but this time the difference is the variables will be on both sides of the equation. So, for example, for the previous ones that we've been doing, the variable has only been on one side, and therefore we've just been moving things around to get the x by itself, right? For whatever that might be. Ooh, come on, man. There you go. Today, the variable is going to be on both sides. So we're going to need to figure out what we need to do to be able to get the variable, all the variables on one side so that we can isolate that variable. So our learning target today, the thing that you want to be able to do is use your knowledge of solving equations to solve equations with variables on both sides. So none of the things about solving are different here, okay? I'm throwing that out there. The same three things we talked about yesterday. Isolate the variable, right? Isolate the variable. It's writing weird this time. I don't know why it keeps randomly cutting out. That says isolate the variable. It's like lots of little things missing to make that hard to read, though. We're going to isolate the variable. We're going to use inverse operations to do that. And we're going to make sure that we do it that operations happen on both sides. Those same foundations apply, just like they have on our previous problems. It's just now we're going to be dealing with something where we need to get all the variables on the same side first. So let's move on and do it. So our first example today, it looks like this: 7 minus 8x equals 4x minus 17. And I'm actually going to kind of split this one up a little bit because the reality here is that we have a few different ways that we can solve this. I'm going to choose 3 of them. And, and it all just depends on which order we want to do the steps. So let's do each of these with, oops, that's not 7x. Let's do each of these using a different order each time, and you will see that in the end we're going to end up with the same answer each time because it's the same equation. It's just we can actually we have a little bit of freedom in the order in which we need to do things. So the main thing we need to do here is get the variables on the same side, right? We need variables on the same side. And so I would suggest as a first step that you want to do something to get the variables on the same side. So, for example, let's move this 4x to that side. Let's get rid of it on the right-hand side. So this is a positive 4x. So I'm going to use an inverse operation in order to move it to the other side. So I'm going to subtract 4x from the right, which means I can subtract 4x from the left. Now notice that these are like terms. The 7 is not the same term as the negative 4x, and so they're not like influencing each other. But the negative 8x and the negative 4x are the same term. So over here, the 4x minus 4x goes away, and so on the right-hand side of the equation, we're left with negative 17. On the left-hand side, we have this 7, which is just kind of hanging out. But then we have negative x minus 4x, which is negative 12x. Notice now that all of the variables are on the same side. The equation that we have is very similar to the equations we've been solving. Let's get the x by itself. The first thing I'm going to do is subtract 7. That's going to give me negative 12x. Notice that the sign right here stays with the 12. Negative 17 equal minus 7 is what? Negative, what is that? Negative 23? Negative 24? Negative 24. And then here we're going to divide both sides by negative 12. And we're going to end up with x equals 2. Let's try this middle one. Let's do a different step first. On this first one, the first thing we did was we subtracted 4x from both sides to move the negative 4, the 4x over this way. This time, let's move the negative 8x over there. So I'm going to add 8x to both sides. And when that happens, the negative 8 and the positive 8x, they cancel out and become 0. So on the left-hand side, we're left with 7. And on the right-hand side, we have 12x minus 17. Notice that that is a different equation than the one that we were working with over here, but it is an equivalent equation. These two equations are equal to each other. They just don't look the same. And now we're going to finish solving this one. We're going to add 17 to both sides. That's 24. Notice that that was kind of a familiar number that we got over here. Except this time, instead of it being negative 12x and negative 24, it's positive 24 and positive 12x. And then I divide both sides by 12. And I end up with that same x equals 2. Let's do a third thing. So I did the variables as the first step. Let's do one of the numbers as a first step. Let's take this negative 17 and have our first step be to move the negative 17 over to that side. So that's minus 17. So I'm going to do the inverse operation and add 17, which means I'm going to add 17 over here. And notice that the 7 and the 17 are the ones that are like terms here, not the negative 8. So this is 7 plus 17. There's that 24 that's also familiar. Minus 8x equals 4x. And let's see, what do we want to do next? Well, we need to get all the variables on the same side. I would say that if I brought the 4x over here, then I'd be left with 0, and then I'd have to move the 8x over just to be on the opposite side of that number. So that's kind of counterproductive to do that. So let's move the negative 8x to this side over here. So what we're going to do is add 8x to both sides. And that's going to give me 24 equals 12x. And hey, look, that's exactly like the last problem now. So I divide both sides by 12, and I end up with x equals 2. So notice that there's a variety of steps that we can do first in this case. And in all cases, we're going to end up with x equals 2 in the end. And we can be certain that that is our correct answer, because if I take that 2 and I plug it in over here, this is actually, let's just let's clear off a little bit of space here in the middle. And let's plug in the 2. 7 minus 8 times 2 equals 4 times 2 minus 17. Notice that those are, I'm just taking the solution we've said it is, and we're plugging it in. Let me ask you a quick question and just answer it to yourself. If this is the correct solution, what should happen when I simplify these things down? Think about that for 5 seconds. Maybe pause the video. Think about that. Okay, that's enough thinking. What should happen? Well, let's find out. That's 7 minus 16 equals 8 minus 17. And 7 minus 16 is negative 9. And 8 minus 17 is also negative 9. Notice that it makes a true statement. And that's what should happen if it's the correct, if 2 is indeed the correct solution. I should plug it in and get a true statement. And I do. So it checks out. All right, let's complicate matters a little bit. I've got another example for you here. 9x, or excuse me, not 9x. No, yes, 9x. 9x minus 5 equals 1/4 times 16x plus 60. Now, before I do any of this moving things left, right into the different sides of the equation stuff that we did on the previous one, I want you guys to note that there is over here something with distributive property. We're going to need to either distribute the 1/4, right? Multiply 1/4 times 16x and then multiply 1/4 times 60, which is a perfectly reasonable thing to do. Or we can multiply both sides by 4 to eliminate that 1/4. I think what I'm going to do is multiply both sides by 4. You can do either though. So I'm going to multiply this side by 4. And if I'm multiplying both sides by 4, I have to make sure that I'm multiplying every term on the other side. So these 4's cancel. And on the right hand side, we're left with 16x plus 60. And on the left-hand side, we're distributing the 4, so that's 36x minus 20. And now we're going to solve it the same way we did last time. We've got a couple different ways we can start it. What I'm noticing is that if I were to subtract 16x from both sides, that's going to make this a nice even number. So that's what I'm going to do. I'm going to subtract 16x, and then I'm going to rewrite my equation. 20x minus 20 equals 60. And from here, we're going to add 20, and we're going to get 20x equals 80. And then as our final step, we're going to divide by 20, and we're going to get x equals 4. And that's our final solution. So same thing, if we need to move the variable terms around, we add or subtract. Sometimes we're going to have to do some simplifying first. So we might have to distribute, we might have to multiply by 4 to move something around, okay? 2 more things today. We got a word problem here. A car dealership sold 78 new cars. Let's use something other than black. Black is boring on black. Black on black, not good things. Okay, let's do it this way. 78 new cars and 67 used cars this year. The number of new cars, this is new cars now, sold by the dealership has been increasing by 6 cars each year. The number of used cars sold, now this is used cars now, sold by the dealership has been decreasing by 4 cars each year. If these trends continue, in how many years will the number of new cars sold be twice the number of used cars sold? All right. We need to create an equation to model this. So one thing that I want you to recognize here is it's asking us, when will number of new cars sold be the same thing as twice the number of used cars sold? So what that's saying here is there's an equal sign in the middle. And on one side of that equation, we have new cars sold. And on the other side of the equation there, we have 2 times used cars sold. So we're going to need to go into this equation here, and we're going to need to look at how can I model new cars sold, and how can I model used cars sold. So let's see, how can I do this? The number of new cars sold has been increasing by 6 cars each year. So that means if I were to take the number of cars that I had and multiply, or the number of years that have gone by, right, and multiply it by 6, that'll tell me the increase in them in what we're looking for. Notice that it's asking for how many years, right? Because it's asking for how many years, that's the thing that's unknown. I know that my variable that I'm using here, and I'm just going to use x, is number of years. Okay, so how can so going back to new cars sold, I know that if I take 6 times the number of years, because I've been increasing by 6 every year, That'll tell me just how many new cars are being made in the future years. But I started with 78. So I can go like that, right? So that's 6 cars per year plus the 78 that I've already sold. Recognize if I plugged in 1, so it'd be like the following year, how many cars were sold? Well, if I plugged in 1 here for 1 year, it would be 6 plus 78, which is 84. If I plugged in 2 here, I'd be adding 12, which would be 90. And that's just the number of cars that there would be. Okay, so that is the new cars sold. Let's make the used cars sold. So first of all, this needs to be, what color? Let's do it in blue. This needs to be 2 times that. So I know that whatever I model here, it's going to be 2 times that. And so this one is 67 cars now, and it's decreasing by 4. So I know that it would be 67 minus 4 every year. So I'm going to start with 67, and then I'm going to lose 4 every year, which means that if x were 1, I'd be losing 4. That makes it 63. Okay, that looks good. There's an equation. I can solve this equation. And if I solve this equation, it'll tell me the number of years until this one is twice as equal. So let's go ahead and do that. And that's going to be the same thing that we've been doing. Let's do this distribution first, huh? So this is 6x plus 78. We're just rewriting that. And let's distribute the 2. 2 times 67. 2 times 60 is 120. 2 times 7 is 14. So this is 134 minus 8x. And let's see. Let's get all the variables on one side. I can recognize that if I move this 8x right here, the negative 8x here, and I add it to both sides, I'll end up with a positive number over here. That's generally a way to make it easier. So this is 14x plus 78 equals 134. And from here on in, it's same old, same old. We're going to subtract 78. And so that's going to be 14x equals, let's see, 134 minus 78. 134 minus 8 makes 126. And then I subtract 70 from that, 56. Right? And then last step, we're going to divide by 14. I'm going to run out of space. And x equals 56 divided by 14, so it's 14, 28, 42, 56. That's what, times 4, right? Yeah, times 4. So that's, come on, there you go. X equals 4. So in 4 years, if this trend continues, the number of new cars will be twice the number of used cars sold. Last thing today. Number of solutions. As it turns out, sometimes when we solve, we end up with no solutions. Sometimes we'll end up at the end and there will be no correct answers. There will be no answers that work. And then other times we'll have many solutions. In fact, I might even go, I would even say this is going to be infinite solutions, meaning that every single number works. So I want to give you 2 examples of that before we go here. So 3x equals 3 times x plus 4 is one of my examples, and the other one is 2x plus 10 equals 2 times x plus 5. So let's do the one on the left first here. Let's distribute the 3. 3x equals 3x plus 12. Let's get all the variables on the same side. So I'm going to subtract 3x and subtract 3x. And wait a second. That's weird. Because that cancels out and becomes 0. And so the right hand is 12. But this cancels out also and becomes 0. And now I have a statement here that says 0 equals 12. Does 0 equal 12? No. That doesn't work, right? That's a lie. It's a false statement. When your solving comes down, and in the end, even your x term gets eliminated and becomes 0, this right here means that there's no solutions. Notice that it makes a false statement at the end. And when it makes a false statement at the end, like that right there, because this is a false statement, right? 0 does not equal 12. That means it's no solutions, right? So this is a case where there's no solutions. Now this one over here, you want to guess how many solutions it has? Let's solve it. Let's see. We're going to distribute the 2. 2x plus 10. Now that's already strange, because this is 2x plus 10 equals 2x plus 10, and those two things are the same. Let's finish solving this. We're going to subtract 2x from both sides, and that's 0 plus 10 equals 10. And then if I subtract 10 from this side, I end up with 0 equals 0. Well, it's weird because I don't have an x anymore, but it is a true statement, right? That is true. 0 does equal 0. And so what that means is this one here. There is an infinite number of solutions. It means that no matter what number we plug in for x, they are all going to work. Every single number works. If I plug in 1, this will make a true statement. If I plug in 100 billion, this will make a true statement. Every number works. This number, there are no numbers that work. It will always be, there's no number that I can plug in for x and it'll make it a true statement. This one, I can plug any number in and it works. So sometimes when we solve, these weird cases happen. And so you will need to keep an eye out for that. And that's it. It's over. Can I write on this page? It's over. Nope, I can't. I can't write on that page. It's mad at me. Alright, let's discard those. And that's it for today. For your video anyway. You've got some problems to do. There's a check for assessment right after this. So you're going to want to do that and get that checked off with Mr. Dilly.